Okay, let's do problem 5 on the practice exam. We're using the closed interval method to find the absolute max and absolute min of a continuous function. And so, long story short, we are taking some derivatives and setting them equal to 0. So let's just do that first. If you want to look in the book and see the outline for the closed interval method, you might want to pause the video and do that now. What am I saying? You guys have already tried to do this problem yourself, right? And probably successfully. But take the derivative. Oh, geez. Let's take the derivative, and we get f prime of t is equal to, I'm going to use the product rule. You could multiply in if you wanted to. I get the cube root, I'm taking the derivative of the cube root, and 1/3 pops out, and I get t to the minus 2/3. I leave the other part alone, and now the product rule tells me that I have to do plus. Actually, if you think about what I'm going to be differentiating now, it's 8 minus t. The derivative is just going to be -1. So I could save myself some trouble and just say minus the cube root of t. Okay. And so I want to set this equal to 0 and solve. And there's several ways to do that. I'm considering putting things over a common denominator. This is actually, you can see that it's really a fraction, right? Let's do that. So I'm going to cut it. I'm going to bring it down here. I'm going to paste it. There it is. So how can I write this as a fraction? So it's equal to 8 minus t on top and 3 times t to the 2/3 on the bottom. You could write that as the cube root of t squared if you wanted to. And minus this thing. Okay, so this is just something over 1. Maybe I should just go ahead and doctor this up and put it over the common denominator, which is 3 times t to the 2/3. So what I have here is the cube root is the same thing as t to the 1/3, and that is over 1, right? So to put it over the common denominator, I multiply top and bottom by t to the 2/3, 3t to the 2/3. And you know that these exponents add. But look, what is 1/3 plus 2/3? Gosh, it's 1. So that's nice. So you just have 3t on top, and then 3 times t to the 2/3 on the bottom. That's fine. So let's write it like that. So now I have minus 3t. Okay, so this is all equal to 8 minus 4t over 3 times t to the 2/3, and I'm setting this equal to 0. Notice that if I put 0 in here for t, it breaks it, right? You get 0 in the denominator, so you're thinking, is 0 a critical point? The only thing we have to check is that, well, I'm assuming that you know what a critical point is. If you don't, look up the definition right now and memorize it for the rest of your life. To see if 0 really is a critical point, we have to make sure that it is actually defined for the original function, and you can see that it is. Plugging in 0 is no problem. So that is a critical point, so we need to add that to our list of critical values. But notice that it's also an endpoint. So we're going to, when we do the closed interval method, we'll be checking that value anyway, so we can just forget about that. And to solve this equation, let's just worry about the numerator now. So set the numerator equal to 0. And I'm not even going to bore you with the algebra. You can just see that t is equal to 2. Super fantastico. Now what I do is I take my list of critical points, which includes 0 and 2, and I combine that with my set of endpoints, and I check the value of the function at each of those. So I need to check just 3 values here. F of 0, f of 2, the critical point, and f of 8. Okay. So you can see that when I plug 0 in, 0 comes out. Also notice that when I plug 8 in, 8 minus 8 is 0, so 0 comes out. And what happens when I plug 2 in? I get something kind of weird. I get the cube root of 2 times 6. Okay, cube root of 2 times 6, fine. And actually now I'm done, because the closed interval method says that once I do this, the biggest number that comes out is the max, and the smallest number that comes out is the min. So I have a tie for a min here. And these are the absolute maximum and minimum values, but with the way I wrote the answer blank here, you can see what I really want is the x value. So the minimum, the x value that minimizes the function is either 0 or 8. And the x value that maximizes the function is 2. Okay, done. Great. Now let's take a look at good old part B. Make my eraser bigger. Okay. Okay, so let's get to work on part B. Maybe I could just start with the derivative. I hope you can see the function. It's x divided by quantity x squared plus 1. So when I take the derivative using the quotient rule, this is what happens. I get x squared plus 1 minus x times 2x. You guys don't need any coddling with the quotient rule, right? I think everybody knows the quotient rule pretty well. And now we're done. Let's see what happens when the dust clears. Going to combine stuff in the numerator. And let me just see, what is this? This is negative 2x squared, right? So if I've got x squared and I take away 2x squareds, that leaves me with negative x squared. This is plus 1. And on the bottom I have x squared plus 1 squared. What I want to do is set this thing equal to 0 and think about the things that either break it or make it 0, or make that equation true. So if you look at the top, you can see that one obvious set of solutions is plus and minus 1. Notice that x equals plus or minus 1 makes this relationship true, because it makes the numerator 0. What about the denominator? The denominator has no zeros, right? So the denominator is useless to us. We could actually, since it's never 0, we could actually multiply both sides by it and forget about it. So we have the solutions, we have the critical points. They are plus and minus 1. Okay. So we'll store them in our highly reliable memory. Now for part B, we need to check these values. We need to check the value of 0. And you're saying, oh my god, what about the negative 1? Forget about negative 1. Negative 1 turned out not to fit in the interval that we care about, and so we just drop it. And we also need to check the other endpoint too. So compute these values. This gives you 0. This gives you 1/2. This gives you, I'm going to have to think, 5 on the bottom and 2 on the top. 2/5. Now you're wondering, which one's bigger, 1/2 or 2/5? I think you'll agree that the answer is 1/2. Okay, so the x value that gives the maximum is 1. Okay, that was the x value that made the maximum come out. Now what x value makes the minimum come out? Well, 0 is the minimum value. The input that makes 0 come out is 0. And we're done. This problem's over.